So welcome to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some GCSE Maths higher revision big mark questions taken from some past papers. Now as always there'll be a copy of the questions for you to download and have an attempt at before watching this video as we go through the answers, and I'll also include the mark scheme so you can see that if you have tried and done an alternate method you can also see whether that is valid and still get you the marks. Now before we get started working through these questions, it's important to note that if you see the 5 questions we're going to go through, that a lot of the questions do have a combination of completely different topics. So looking at question 1, we've got a combination of knowledge of equations with circle theorems. Question 2 is less so much because it's about quadratics, completing square and turning points. Question 3 is including compound areas and equations. Question 4, circle theorems makes a return, with this time mixed in with some ratios, and compound units and bounds. So let's get started on question 1. So question 1 says that A, B, C, D are points on a circle, B, F, D and A, F, C are straight lines, D to C is equal to D to F. Work out the size of angle X. You must show your working out, which may be on the diagram, which is always useful. Now if you have not had a chance to print out any of these questions, then all you need to do is just simply pause the video as I'm reading out the question, have an attempt at it, and then see how you would fare to get the right answer. So looking at this particular question, let's have a look at what we know. Now with regards to this, if it did say that we had to explain how we got our different angles, then it's always important that you know how to use angle notation to make sure it's the right thing. So here, rather than saying angle E, because that could be one of two or multiple questions, like for example if I want to work out angle F, well there's 1, 2, 3, 4, 5 possibilities that could be classed as angle F. So what you want to do is make sure that you are using the correct notation and not scribbling out the whole entire question. And let me just get rid of that there. And so in terms of angle notation, so for example if I want to describe this angle here, then I would represent that as E, F and D with either a little hat on F, so it's a middle angle, or you could represent it as with a little angle and then EFD. So any of those would be absolutely fine in terms of notation. But anyway, back to this question. So here, let's have a look at what we've got. So from this, I can see a circle, so I'm thinking circle theorem. So then going through all my knowledge of circle theorems and seeing what can I see. Can I see an arrowhead? Can I see a quadrilateral? Can I see a tangent? Can I see a radius, etc.? One thing I do notice I can see is I can see a bow. So here is my bow, and so once I've identified that, I then think to myself, okay, well what do I know about the bow? Well, I know that this angle here and this angle here are the same, so this angle here is going to be 24. I just write down the bow. This is just for this video purposes, but I would say typically speaking you'd get away with just writing 24. Now the next thing I note is that this triangle here is an isosceles triangle because two sides are the same. So that means then to work out what this angle here is, to work out all that angle there, all I need to do is do 180 minus 24 all divided by 2, and if I work that out, what I get is 78. So this angle here is going to be 78 and this angle here is going to be 78. Then from this, what I then know is that all of these three things here, because they lie on a straight line, that angles add up to 180 degrees. So 2x plus x plus 78 add up to 180. So if I neaten all of this up, I get 3x plus 78 equals 180. 3x is going to equal 102. And x is going to equal 102 divided by 3, which is 34 degrees. And there is my final answer. Now moving on to question 2, it says here is a sketch of y equals x squared plus bx plus c, and it says that the curve intersects the x-axis at 5, 0 at point P and the y-axis at 0, minus 10. And the question is asking us to work out the x-ordinate of the turning point of the graph. So for this, what we need to do is we need to use this information to help us work out what the quadratic equation is of the curve. So if I just set up my double brackets, that from this, as one of the roots is 5, that means that one of the solutions must be minus 5. And because we're dealing with a single x squared, that in both brackets we're both going to have an x, a single x in both. Now looking at this, we also know that the constant is also where it crosses the y-axis, and we've been told that that's minus 10. So this number plus another number must multiply together to give me minus 10. So therefore a must equal positive 2. So I can scribble that a out and write plus 2 instead. Now from this, what I've then got is the equation of the curve. Now to find the turning point, what I need to do is expand that out. So I get x squared minus 3x minus 10. And then what I now need to do is get into a point of where I'm writing this in completing the square format. So y equals, and then here I've got x, and I've got my bracket, I've got minus 10. And then to get the number inside the bracket, I divide the coefficient of x by 2. So that becomes that. And then I take away whatever numbers inside the bracket squared. So that's going to be 9 over 4 or 3 over 2 squared. So I'm just going to write 9 over 4. Now for this, the question's only asking for the x ordinate. So all I then need to do is then the x ordinate of the turning point is going to be positive 3 over 2. Now if you want to know what the coordinate was, it's going to be, so the turning point, this point here, is actually going to be 3 over 2 or 1.5, and it's going to be minus 49 over 4. But again, it's not essential for you to write down the coordinate because it's only asking for the x ordinate, which is really important that you do read the question and try not to give too much information by guessing the question without reading it properly. So here x equals 3 and over 2 or 1.5, whichever floats your boat. Moving on to question 3, it says here is an L shape, all dimensions are in centimetres and the area of the L shape is 65 centimetres squared. Work out the value of x. Now for this, there's one or two ways you can do this, and it all depends on how you split this L shape up. Now I'm going to split this up, and it doesn't really matter which way you do it. I'm going to split it up like this. So if I split it up like this, what I then need to do is I need to work out the area, the expression for the area of A and the expression for the area of B. Now for A, that's just going to be the length times the width, so that's just going to be 9x. I'm going to put a little box around that. Then for B, well, the height is 3x plus 1. I'll put brackets around there because we've got an expression. So the next thing for me to do is to work out what this length here is going to be. Well, if all of this length here is 10, and we need to take away x, that's going to be 10 take away x. So then what I've then got is this. Now, so then there, what we've got is the area, which is going to be 9x plus 3x plus 1, 10 minus x, and that's all going to be equal to 65. So from this, if I expand the brackets out, I get 9x plus, and it's going to be 30x minus 3x squared plus 10, and it's going to be minus x, and that all equals 65. So then neatening all of this up, I end up with minus 3x squared, then I've got plus 38x, and then I've got plus 10 equals 65. Now because I've got a negative x, I want to take that all over to the other side. So what I do is I take that all over to this side to try and keep the x squared positive. So I end up with 3x squared minus 38x, and it's going to be plus 55, and that equals 0. Then from this, what I then need to do is then go on and solve this. So here I could solve it a couple of ways. Either I can factorize it, or I can use the quadratic formula. At this stage, you might be thinking to yourself, let's use the quadratic formula. So here a equals 3, b equals minus 38, and c equals 55. So from this, now personally speaking, I think this will factorize. And let's just have an attempt at factorizing this. So I'm guessing with 55, we probably need 11 and 5. And they're both going to be negative. So here we've got an answer of x equals, it's going to be 5 over 3 or minus 11. or positive 11. Now from this, if we look at the values of x, which of these two values could it be? Well, can it be 5 over 3? Yes. Could it be 11? Yes. But the problem is that it can't equal 11 simply because if x was 11, these sides here wouldn't quite work. I'll end up with a negative length. So this could be 11, but that would be -1. That's not going to work. So the only possible value of x you can have is going to be 5 over 3. Now looking at question 4, it says here is a cyclic quadrilateral, and it says that we need to work out the size of angle W. So let's have a look at the circle theorems that we know and what we know about a cyclic quadrilateral. Well, what we know and what we should know is that opposite angles add up to 180. So what I've got is I've got x plus 20 plus W equals 180, and if I do a bit of rearranging, I get x plus W equals 160. I'm just going to put a little box around that because that's something that I did need to know. Another property that we've got is that x plus y equals 180. And there is our another fact. Now, another fact that you should be able to know is that all 4 of those angles need to add up to 360. But how useful is that going to be? Well, it's not going to be very big, simply because I'm going to end up with 3 letters in the equation, and I need to find out what one of those letters are. So from this, what we can then do is do the following. So here, now using this ratio, if I convert this into an equation, so I end up with x over y equals 5 over 7, and if I then cross multiply, I get 7x equals 5y. So let me just put a little box around that. Now from this box here, if I make one of the letters the subject, so it doesn't really matter which one we go for, so let's go for making y the subject, I end up with 7x over 5 equals y. Now, if I then substitute this into the orange box, then what I end up with x plus 7x over 5 equals 180. Then from this, if I try and eliminate this 5 and I multiply everything by 5, then this 5 cancels with that one and end up with 5x plus 5 times plus 7x, so because obviously the 5's cancel, and 180 times 5 gives me an answer of 900. So neatening this up, what do I get? Well, I get 12x equals 900. So x is going to equal 900 divided by 12, which gives me an answer of 75 degrees. So this angle here is 75. This angle here is going to be 75 plus 0, which is 95 degrees. So then from this, now that I know that x equals 75, I've got x plus w equals 160. 75 plus w equals 160. So w equals 160 minus 75, which gives me an answer of 85. So w equals 85 degrees, and there is my final answer. Then moving on to our last question, it says the dimensions of a rectangular floor are to the nearest 0.1 meters. A force of 345 newtons is applied to the floor. The force is to the nearest 5 newtons, and so it gives us the formula for pressure, which is force over area. And the question is asking us to work out the upper bound of the pressure, and we need to give our answer to 4 sig fig. So the first thing we need to do is look at the upper limits of each of these things. So here we've got 0.01. So to work out the length of the max and the minimum length that these could be, what I need to do is do 2.6 plus or minus half of the rounding error, which is 0.1, divided by 2. So let me just do that now. So that's going to be that divided by 2 equals 0.05. So what I'm going to do is with 2.6 is I'm going to plus or minus 0.05, and I'm also going to do the same with 6.4. Then with the newtons, that's been rounded up to 5 newtons, so that divided by 2 gives me 2.5. So then the upper lower bound of the pressure is going to be 345 plus or minus 2.5. Now from that I can then work out what the upper and lower bounds are going to be. So for this it's going to be 6.35 to 6.45. This is going to be 2.55 to 2.65, and for this it's going to be 342.5 to 347.5. Now for this, to get the maximum fraction, so to get the maximum pressure, I need the biggest number at the top over the smallest number at the bottom. Now for this, what I need then is the biggest area and the smallest, the biggest force and the smallest area. So to get the biggest force, well, that's going to be 347.5 over, now to get the smallest area, I need to use the smaller lengths of each of those. So it's going to be 2.55 multiplied by 6.35, and typing this into my calculator, so it gives me 347.5 over 16.1925, and if I type in all of this fraction into my calculator, what do I end up with? Let me just do just that, and I end up with an answer of 21.46055.273. Now remembering I need to give my answer to 4 significant figures, so that's going to be those 4 there, so it's 21.46, and the units are given to me in the answer, so it's going to be newtons per meter squared, and there is my final answer.